Hey, this is Nick from JangaFX, and today we're going to be teaching you how to use our brand new Unity vector field plugin. This plugin allows you to affect both particle systems and rigid bodies with vector fields that were created within VectorayGen. If you aren't familiar with vector fields in VFX, a vector field is simply a grid or a bounding box full of vectors which we can represent as arrows. And each of these arrows tell a particle or rigid body what direction to go and at what velocity. And so if you have a tolerance of 1, the particles will be calculated with a velocity, and I believe that if the tolerance is 0, then it will just add acceleration to these particular particles or rigid bodies. If I click play, you can see that the particles swirl up and down, and the reason why it stopped right there is because we have this intensity for the vector field set at a certain animation rate on a curve. And so we can change the intensity over time, based on whatever curves you want to set if you want to. Be sure to watch the entire video if you want to fully understand every feature this plugin has to offer. And then I want to say that this plugin was created in collaboration with Gil over at IgniShot, and without his help it wouldn't have been possible for us to create this ourselves. Gil will also be narrating the tutorial portion of this video, and so I'll go ahead and pass the spotlight over to him, and I hope you guys learned something.
Hi, in this video I will show you how to export a vector field from VectorayGen to Unity using the new Unity plugin available on the Asset Store. So first we will build a quick vector field in VectorayGen. So I will try to make something like inward blobby shape. So I will first use the noise as base. I will increase the frequency to have higher frequency and interesting things going on like this. I will now make everything go inward. So I will use another generator, a fade generator. I will simply change the max value to -1. So everything goes inward. And now I will blend those two nodes using a select. The select, well, I will use a sphere for the shape, like this. I will also reduce a bit the size of the sphere to avoid having the problem on the edges. I want to have everything going inward. So I will lock the axis and will choose 200 as a size, like this. Okay, it seems to be what I want to do. Blobby going inward, perfect. So once you've done your vector field, you can simply export it using the file export vector field, and you will export it as a FGA file. So I will simply choose my destination directory and I will name it blobby inward.fga. Okay, so my file is now saved. I can leave VectorayGen and go to Unity over here. So in this Unity project I just have the plugin for now, and I have my test directory with the blobby inward vector field. So how to create the vector field in the scene? You have to create first an object. So you can create an empty game object like this, and on this game object I will simply add a component, and the component will appear here in the vector field category. So you have a vector field, particle controller, particle emitter, and rigid body controller. We will see that later. So now we will use the vector field. So you have your vector field now, and you have to select the source of the vector field, the file. And for that, simply here in the vector field file, select the file you want. This will enumerate every FGA files you have in your project. So all the VF stuff, there are samples that you can find in the plugins, and you have the Blobby inward, which is my my exported vector field. So you can see all the arrows here in the gizmo, and you have a pretty good idea of what this vector field will do. So you can change a lot of things here, either visually or simply the intensity of the field and stuff like that. Concerning the selection of the vector field, if you want to change the value of your vector field, you can simply change this using another file, and it will just have the vector field exactly at the same place. You just notice that the size is different. It's because by default it's loading its size from the vector field file. We'll go back to my Blobby inward. You can see the size of here, so it's 5.12 meters. If you have modified the file and you want to reload it, you have the reload button, and you can also quickly rename from file, so it will basically change the name of your game object using the name of the vector field. It's just quick, so if you have several vector field in the same scene, you can easily name them using the vector field file name. Under all of this you have little tabs with 4 tabs. You have the bounds, you have the intensity, the size, and the gizmo. First, let's have a look at the gizmo. You can decide not to see the vector field at all, never. So you just uncheck the show gizmos, and you will not see anything. You can also decide if you want to see the vector field only when it's selected, it's the default behavior, or always. So if I select something else, let's say the light, you see the vector field, you see only the bounding box but not the vector field. If you want to see it all the time, you can simply go to Gizmo and select always display vector field. So when you select something else, you will see always the vector field. And you can also select view mode, view style. So you have scaled arrows. So the size of the arrows define the intensity at that place in the vector field. You can have colored arrows. So the color of the arrow define the orientation of the of every cell in the vector field, and also the intensity. Or if you want something lighter, you can have colored lines or scaled lines. You can also select the scale of the gizmo. So if you want to have just very small lines or arrows, you can have a very small value, or if you want to increase that, just select the gizmo scale. And you can change also the color. So if you want to have bluish, magenta, green arrows, whatever you want, just select that. And you can change also the translucency. So that's it for the gizmo. Then you have the bounds, and that defines the behavior outside of the bounding box of the vector field. So by default it's closed. That means everything inside the box will be affected by the vector field, and outside the vector field will have no effect at all. So you can change different choose different behavior here. So it can be either border, that means that the first and the last value will be repeated indefinitely. So for instance, if I look at this face, I will use these values and repeat these values indefinitely on the left. Same goes for the right. I will use all the values here and repeat that on the right. So that means in this case that everything will be sucked inside the box, even if it's outside of the box. Then you have repeat. Basically, it will take the vector field and repeat it indefinitely on the right, left, front, back, top and bottom. Then you have mirror. So the access to the vector field will be mirrored. So you will have the regular vector field, then next to it you will have a mirrored version of the vector field. It's only the access to the vector field that will be mirrored. The orientation will not be flipped. And this just allows some very interesting effect to have the mirror. And you can also choose to do different settings per axis. So you can say, okay, on the x-axis I want to have something that is close, on the y I want to have it repeat, and on the z I want to have it mirror, for instance. I will choose just close for the moment. And whenever you have a closed option, you can have a ramp. So the ramp is basically a transition ramp from the outside to the inside of the vector field. So by default it's 0. That means if you are just outside of the vector field, you are not influenced at all by the vector field. If you are just inside, it will be 100%. With the ramp, you can basically fade that on the border of the vector field. Then you have the intensity of the field. You can simply change the value. So if you increase the value, you will see directly the gizmo that will change in size. You can of course have a negative value if you want to make everything goes outward. And you can also do a quick, easy animation with the animate option here. So if you check that, you can have a curve animation that will repeat again and again. So for instance, I will use a simple straight ramp from 0 to 1. And by default, I'm in forward mode. So that means I will make the animation start at 0 and then go to 1. And then go back to 0 and go to 1 and so on. You can change the duration of the animation. So if I increase that, it's of course slower. If I reduce it, it will be faster. I will make it, let's say 5 seconds here. You can also change the direction of the animation. So you can make it forward, backward. So that means that it will start full and then decrease. And you can do a ping pong. So it will go forward and backward and forward and backward and so on. And all of these value animated can be multiplied by a value here with the intensity. So if I put 3 here, it will go from 3 to 0 to 3 to 0 and so on. I will put it to 2 and go to the next tab. Okay, the next tab is the size. By default, it's using the size from the file. So it will use the exact value that you have entered in VectorayGen. If you want to change that, you just uncheck this one and you can give whatever size you want. So if you want to have your vector field to be 10 meters by 10 meters by 10 meters. Okay, here we go. And then if you choose another vector field, whatever is inside the vector field will be ignored for the size. So I can choose another one here, another one. Everything will have the size you have decided. So it's 10, 10, 10 here. Okay, now let's use the vector field. Okay, so first scenario, we will use the vector field to affect particle system. So I will just create a particle system over here. At the bottom of the vector field, like that. And to affect the particles in the particle system, I need to add component vector field and particle controller, like this. So you see directly as I've done that, you can see that the particles have different behavior. So what can I do here? I have several options. I will increase a bit the size over here. So you can say, okay, I want to have my particle system affected by all vector field I got in my scene. This is the default behavior, but if you have lots of vector field, it can be a problem for the performance, because that means you have to check all the vector field and combine their forces. So if you want to be more efficient, you can simply say, okay, not all vector field, but just a selection of vector field. I will say, okay, here just one, because I have only one in my scene. And the first one I want is this one, the blobby inward. So that means if I put another vector field in the scene, it won't affect those particles. Then you have the multiplier, and then you have the tightness. The multiplier is simply the multiplier on top of the forces of the vector field, or vector fields if you have more than one. So if I increase the value, you see it got faster and faster. And here you see some particles that are just shaking. Why is this happening? It's just because the vector field we have created has convergence. That means that lots of vectors are pointing to the same place. And so basically the particles are stuck inside those places. Why is this happening? Because we are in high tightness mode. The tightness of the vector field or the particle controller is basically if you want to use the vector field as a source for the speed of the particles. So you put a tightness of 1. If you want to use the vector field as a source of forces and not speed, then you can reduce that to 0 or something in between. That will be a mix between forces and speed, which is often the most interesting value, let's say in between 0 and 1. So you see that the particles are moving, and then it gets quieter, let's say, and then it's moving again. It's simply because we have the animation on the vector field, if you remember. I will go to my blobby inward vector field, and in the intensity I got the animation. If I remove the animation and go to my particle system, then it will go on and on and on. Like this. So I can now tune the multiplier, say maybe a bit less than that to have slower particle, and the tightness So if I have too high value, I will have the particle stuck here. And if I have too low value, they will just basically fly away in every direction. What you can also do is change the tightness or the multiplier value depending on the life cycle of the particles. So by default it's constant during the whole particle cycle. Now let's animate the tightness, for instance. So here you can have a curve, and if I use this one, it will be like before, 1 all the time. So it's 1 multiplied by the tightness here. So that means that it will go between 0 and that value. If you want to have the full range of value, you have to put the tightness to 1 and change the value in your animation curve. It's really up to you to do that. So here I will change the curve here to have something that, let's say, get loose with the time. So we'll put another control point here, and for this one I will put a value of 0 like this. So that means that at the end of their life, the particles will basically have the influence only as force and no more as speed. So maybe I can do something like that, it will be more visible. I will also change the color of the life of the particle, so you can see that the particle at the end of their life will get loose, and the one at the start of their life will be more tight. So just color over lifetime over here, and I will start with bright particles and end with let's say dark blue ones. Like this. So now you should see that the particles, when they are more dark blue, they are getting a bit away of the vector field because they are less tightness. I will just add this to have them fade properly, like this. Okay, it's better. Okay, so now you see you can animate the tightness. You can do the same with the multiplier over here. So this is already a first step. Now what you can also do is add another component in the vector field, which is the particle emitter. So the particle emitter allows you to change the origin of the particles. So I will use, you have to choose a vector field, and from this vector field you can have several options. So I can say I want the particles to be emitted from the vector origin, inside the field, on the corners, on the edges, on the surface of the volume, or on a given face. So I will say for first vector origin. I have to press play to see that in action. Okay. Now all the particles are spawned right where you have vectors in the vector field. So for instance, if I select my particle here. So it's spawning only where you have the base of a green line here. So this is one option. What can you do also? So you can say, okay, I want to have inside the field, so it's anywhere inside the field. You can say on the corner, so the particles are spawned only on the corner. I will maybe increase the particle count on the emission so you can see more clearly. So I will spawn, let's say 500, and max particles, let's say 15,000. I will also reduce a bit the lifetime to 2. And reduce also the start speed to 0. Okay. So with this, it should be okay, and go back to corner like that. So you see now you have the particles emitted from the corner. And you can change that, of course, as you wish. You can change that to edges. So it's spawned from the edges, or you can spawn from the surface of the volume, or just from one of the faces. So if I want to have the particles coming from the bottom of my vector field, I will choose -y here. And so you have all the particles. I will reduce the size maybe of the particles. It should be better. They are big. So the start size 0.25, and I will select so -y. Okay. Okay, now you can clearly see what's going on here. And of course you can fine-tune all of this. You can also, for the emission, you can change the coverage. By default it's 100%, but if you reduce that, it's only a part of the base that is used when you are in face mode here. If you are on edges mode, it's only a part of the edges. So if I reduce it to its minimum, it will spawn particle only on the center of the edges. For the volume, same goes for the volume, it's the center of the faces, and if I increase, it comes from different direction, different faces. And that's it. I mean, you can combine all of this as you wish. Of course, when you have more particles like this, it's easier to see the influence of the tightness. So if I increase the tightness, the flow of particles will follow more the vector field. If I reduce it, it will be more loose. Sorry. And you can, of course, change your animation curve, whatever you want. If I remove that, I will have a constant tightness. Of course, you can at any time change the content of your vector field. So instead of using the vector field I've created, I can select one of the other one here, like constant rotation, like helix concentrate. Maybe I remove the gizmo, so it's better. You have better view of what's going on. So helix concentrate or random. or normalize inward, so everything goes in the middle here. Suction here. Well, you can check all of this and see what's going on. So here, for instance, I will select a larger coverage like this, and you see it's kind of a vortex thing. And of course, you can add other vector field to affect this one if you want. Or you can also change the behavior outside of the vector field. So here it stays in the box, but if I select another one, like no, not that one, sorry, here. If I select another one with helix concentrate, okay, you see it can goes outward and leave that box, especially if I increase the intensity. So here, if I put let's say 5, then it flies away. So what I can do is simply change the bounds. I will remove the gizmo so it will be more clear. I can change the bounds behavior if I want. So for instance, if I put repeat, what's happening is that it's like I have the same vector field but duplicated everywhere, and so that's why you can see some twirls here and there. If I increase the tightness, maybe it will be more obvious. Okay, like this. So you see that once you're leaving the box here, it continues because it's in repeat mode. Now let's change that. If I put border, when you're leaving the box, it's only the value on the top of the box that will be repeated. That's why you have kind of a regular column over here. If I put mirror, I will have all my vector field that will be mirrored on top of another mirror, on top of another mirror. And if I go to the closed, so that was what we had before, I can also change the ramp, as I've told you before. So if I reduce the ramp, of course here it will quickly stop the spawning of particles because they have no basic speed. Another option you have for the vector field is to use rigid bodies. So here I have kept my my settings that I've tested right before using helix concentrate vector field. And if I put some object over here, so I will add let's say sphere like this on the bottom here. Okay, so I put the object here and I will add a component, so it's vector field rigid body controller. So adding the rigid body controller will automatically add a rigid body. I will remove the gravity here to avoid the sphere falling, but if you put a ground, you can do that. Of course, it will stop the fall of the sphere. So same as for the particles, you can select the tightness and the multiplier and say if you want to be affected by all vector field or just one vector field. So I will change the tightness to 0.4 value, for instance, and oh, I've just changed the parenting. The sphere is okay like this, and I will just check to see what's going on. So you see the sphere is also affected by the vector field. So if I just put back the animation of my vector field here for the intensity, remember I got ping pong animation, then you can have some interesting stuff going on. So it will just slow down and then goes back, etc., etc. So with that you can really create a very interesting effect. Here you can put that, of course, on as many objects as you wish, like this. And of course, as you still have the rigid body, it will of course still collide between sphere and doing what you expect from a rigid body object. Okay, that's it. I think it's covering the whole process with the different options you have here. Hope you will have fun with that. There's lots of possibilities. Just be creative and enjoy that plugin.